Let's take a look at another algebraic proof. In this case, we have two sets A and B, and we would like to show that the equality A minus the A intersect B is equal to A minus B. So we begin the same usual way. We're going to write proof by algebraic method, and then let A be B sets. Okay, so typically speaking, what you do next is you pick the uglier looking version of this. So pick the left-hand side in this case because it looks a little bit ugly. And we're going to try to simplify it enough times until it looks like the right-hand side. So I'm going to write down the left-hand side is A minus A intersect B. And I'm going to try to manipulate it as many times as possible. I always do one step per line, and then I write the justification next to it until it looks like the right-hand side. Okay, and again, just like we said before, the minus is the very first thing that must go. Okay, there are 11 other properties in the table that don't have minuses. There's only one property with minus, so we always start with that. Okay, because there's a minus, we can rewrite the problem as A intersect B, and then complement on the outside. This is true by set difference. Okay, so now that we have the complement on the outside, we can go ahead and use De Morgan's law to distribute the complement to the inside of the parentheses. So we're gonna go A intersect A complement, and then union B complement. So this is true by De Morgan's law. So if you have De Morgan's, you give the C to out to everything inside, and you flip the union to intersection or intersection to union. Okay, what I would like to do next is give that A to the outside to the parentheses. So I'm going to distribute the A that's on the outside into A complement, and then I'm going to give the A on the outside to B complement. And keep in mind that since there was intersection on the outside, you're going to get intersection between both of those and the union in the middle, because that was the inside sign. And there's parentheses around everything. This is true by rule number 3, the distributive law. Now, rule number 5, the complement law, says that A intersected with A complement is going to be the empty set. So this can be replaced with the empty set and union the A intersected with B complement. This is rule number 5, the complement law. Now, rule number 4, the identity law, says basically that in the empty set and union with any other set is going to be the other set itself. So A intersect B complement. This is true because of rule number 4, the identity law. Now finally, since I have an intersection with a complement, I can rewrite that last bit as A minus B. And again, this is true by set difference. But this is exactly what we want to show, because that's the right-hand side of the equation. So this is equal to the right-hand side. Therefore, what we set out to do is now true, and we are basically finished.